In Combining Functions Part 2, we're going to talk about specifically composition of functions. I'm going to start off with a simpler form of composition of functions. Composing functions is when you plug the output of one function in for the input of a second function. We have two different notations for composition of functions. Sometimes we write it like this. Sometimes we write it like this. These both say the same thing. It's pronounced f of g of x. The way that it works is, remember that x is an input. You plug that value into the function to get the output y. But that y value, the output, becomes the input of the outside function. And it doesn't matter which notation you use. X gets plugged into g. You get a number output, and that output gets plugged into f. And I want you to look at the direction that I went when I plugged things in. I went to the left. Now, let's talk about this function here at the top. F of x is equal to 3x minus 1, and g of x is equal to 2x plus 5. I want to find f of g of 2. So the way this works is first I plug 2 into g. Well, here's g. I plug in 2 times 2 plus 5. And then I evaluate it. 2 plus 2 is 4, or 2 times 2 is 4, plus 5 is 9. And now I'm left with f of 9. That says plug 9 into the function labeled f. So I'm going to do 3 times 9 minus 1. 27 minus 1 is 26. And that's the final answer. Now I want to show you what happens when I switch the order. This says g of f of 2. The way this works is you start by evaluating f of 2. So to find f of 2, you're going to plug 2 into f. So we're going to do 3 times 2 minus 1. That's 6 minus 1, which is 5. And now you're left with g of 5. That says plug 5 into g. So we're going to do 2 times 5 plus 5. 10 plus 5 is 15. So the order in which you compose your functions changes the answer. You can do a composition of functions with different functions. You can do a composition of functions with itself. Let me show you. Let's say that f of x is 4x minus 8. I want to find f of negative 1. Notice that I switched the notation because I want to show you that it doesn't matter if you use this notation with the little circle or you use the notation like on the previous slide, that the problem is still done the same way. The first thing you do is you find f of negative 1. So I'm plugging negative 1 into f. So 4 times negative 1 minus 8 is going to be negative 12. The reason that this still says f is because there's another function f on the outside. So now this says plug negative 12 into f. Well, 4 times negative 12 minus 8 is going to be negative 56. And that's the final answer. A composition of functions occurs when you take an input, like x, and you plug it into a function, in which case you get an output. But that output becomes the input of the function listed on the outside of the, I used brackets here. A lot of times we use parentheses. Or I could use this notation, which is the same thing. Notice, here's your input. And then you're going to plug it into this function and get an output. But that output is going to become the input of the next function. This works pretty well when you're dealing in numbers. As a matter of fact, we can compose more than two functions. How about I tell you that f of x is 2x plus 3, g of x is negative 5x minus 1, and h of x is x minus 7. How about I say find f of g of h of 1? Well, now this is looking more complicated, isn't it? It works the same way. You always start over here. Start with your input. Plug it into h. So once you plug it into h, then we're done. So 1 minus 7 is negative 6. That output becomes the input of the next function. So now we're going to do g of negative 6. So negative 5 times negative 6 is positive 30, minus 1 is 29. And now 29 was the output of g of x. It becomes the input of f of x. So now we're going to do 2 times 29 plus 3, which is going to be 61, and that's the final answer. Now let's make this a tad bit harder. Let's say f of x is 2x plus 3, and g of x is 3x minus 1. What if I just say, find f of g of x, and I don't give you a number? Well, the output of g of x is this entire expression, 3x minus 1. So what we're telling you to do is we're telling you to make 3x minus 1 the input of f of x. In other words, we're going to substitute the whole entire expression, 3x minus 1, into f of x. Where does it get plugged in for? It gets plugged in for x. So what I do is I take away the original x because that's going to get replaced. And in its place, I put the 3x minus 1. So now I have 6x minus 2 plus 3, which is 2x plus 1. What if I switch the order, though? What if I say find g of f of x? This time, the input is going to be 2x plus 3, because that's f of x. And we're going to substitute 2x plus 3 into this equation in place of the x. So I'm going to take out the x, because we're going to replace it, and we're going to put 2x plus 3 instead. And now we have distribution again, so I have 6x plus 9 minus 1, which is going to be 6x plus 8. And that would be the final answer. It gets a little bit harder when you have to do more complicated math. So, for example, let's look at this. F of x is equal to 2x plus 3, and g of x is equal to x squared minus 1. Let's start by finding f of g of x. This says plug g of x, which is x squared minus 1, into f of x. So we're going to plug into here. So we're going to take away the x. That's the most common thing that students confuse. They forget to remove the original x before they replace it. You got to remove it. And so the way that I account for that is I just leave a big old blank space. In the big old blank space, I'm going to put the x squared minus 1. And now, hey, look, I'm going to distribute 2x squared minus 2 plus 3, and that's going to be 2x squared plus 1. If I reverse the order, g of f of x, I'm going to put 2x plus 3 into g. So I'm going to replace the x with 2x plus 3. Now, when I do that, notice that all I removed was the x. Look at the square. It's still there. In here, I'm going to put the 2x plus 3. In order to simplify this, you have to remember that squaring means multiplying by itself. And then we learned a little distribution trick for multiplying two binomials. You may have learned FOIL. I'm going to do the distribution. I'm going to get 4x squared plus 6x plus 6x plus 9. Don't forget about the minus 1. That's at the end of the equation. And any like terms, I'm going to combine. And I get 4x squared plus 12x plus 8. And that's the final answer. Remember that you can compose a function with itself. So if I say f of x is equal to x squared minus 1, and I want to find f of x, what I'm going to do is I'm going to plug x squared minus 1 into itself. So look at how I wrote this. I'm taking out the x, and I'm going to replace it with itself. Remember, squaring means multiplying by itself. And then I'm going to do distribution. I get x to the 4th minus x squared plus 1. And then there's another minus 1 out here. These are like terms. These are like terms. I get x to the 4th minus 2x squared. These end up canceling and becoming 0. A composition function occurs when you take an input from one function and you plug a number into a function, you get an output. That output becomes the input of the next function. Sometimes we plug in a number, sometimes we just want to find the equation that represents a composition of functions. In the next video, I'll discuss a composition of functions in application problems. Because as you know, you would never do this particular process in a job. But you might do a composition of functions unknowingly, and I'm going to show you that in the next video.